In this problem, we're solving for the velocity of a falling flower pot when it reaches this spot here at the top of a window. By solving this problem, we will get practice using the kinematic equations. The first step is to determine which kinematic equation we should use. We will make this choice based on what we know and what we don't know about the problem. We are told the amount of time it takes for the flower pot to pass from the top of the window to the bottom of the window, the height of the window, how high above the ground the window is, the mass of the flower pot, and we also know its acceleration because it's in free fall, so the acceleration is the acceleration due to gravity. What we don't know is the velocity at the top of the window, the velocity of the flower pot at the bottom of the window, and how tall the building is. If we look at our equations here, we can eliminate using the first equation because the flower pot is accelerating. We can eliminate using the second equation because we have two unknowns, the velocity of the flower pot at the top of the window and the velocity of the flower pot at the bottom of the window. And for the same reason, we can eliminate using this fourth equation here. We are able to use the third equation because we know how tall the window is, we can solve for the velocity of the flower pot at the top of the window, we know the amount of time it takes for the flower pot to go from the top of the window to the bottom, and we know the acceleration is due to gravity. To solve for the velocity of the flower pot at the top of the window, we take our general kinematic equation and substitute in the variables, which we define in this picture here. y2 is the height of the bottom of the window, y1 is the height of the top of the window, v1 is the velocity of the flower pot as it passes through this height y1, and the acceleration experienced by the flower pot is equal to negative g because the acceleration is due to gravity and we're using the standard coordinate system where the negative y direction is down. We solve this equation for v1 and we can substitute in for this difference here negative L, which is the length of the window. We now have an expression for the velocity of the flower pot in terms of quantities which we know the values of. At this point, all that's left is to evaluate the expression for v1 which we just derived. We substitute in the values given in the problem statement to find that the velocity of the flower pot at the top of the window is equal to negative 19.75 meters per second.